Right, now I'm going to continue with the mole. Will you take it, please, that you be given a copy of this in due course? It's the facts about the mole and various questions. And I have 4 questions here. I'm going to add a 5th one to it. I've dealt with the first 2. I'm dealing with number 3 now. How many atoms of hydrogen are present in a cylinder of butane gas if the volume of the cylinder is 300 centimeters cubed? Now remember, all these questions are about the mole, and there's an expectation that you'll be able to deal with them appropriately. Now, once again, butane is given to you there and no formula. I think a Leaving Cert chemistry student would be expected to know the chemical formula for butane, but that's presuming you have a significant bit of organic done and that you're aware of that. But I would be certain that if this was the question on the paper, there would be a previous part of the question where the butane formula would be given. Butane is an alkane. Don't worry about that. It's C4H10. Now I'm working on the premise that you're given that. I'm going to work on the premise you're given that for butane. So you're asked how many atoms of hydrogen are present in a cylinder of butane whose volume happens to be 300. The volume, I'll just write it down as V, I suppose, to stay with my formula. V is equal to 300 centimeters cubed. Okay? And so we are given a volume, and we want to find out how many particles are present. Okay, that's basically what you're doing. So here you go. That's equal to, now be careful, in this case, that's equal to 0.3 litres. 0.3 litres. And we must convert that to moles. So to go into moles, you divide. Nobody said anything about STP here. How many atoms of hydrogen are present in a cylinder of butane gas? The cylinder would be in a room, so it would always be room temperature and pressure. I'm repeating again, it's always RTP unless they say STP. Unless they actually specifically say STP, then it's RTP. And so that's equal to 0.3 divided by 24.0 moles. Now be careful, please, we're talking about C4H10. Okay, H10, and that's C4H10. And let me repeat myself now, please. A number, right? A unit, and a tag, please, every time. Always tell me what you're talking about and you won't make mistakes, okay? So that's your moles. So we've got the moles, right? You evaluate that, and now you get the molecules by multiplying by Avogadro's number. Are you okay with that? That's all that you would need, okay? And that's equal to, in this case, 0.3, okay, divided by 22.4 and multiplied by 6 by 10 to the power of 23. And please remember that is molecules of C4H10. Now, this is one of the more popular questions in Leaving Cert. Be careful, they keep asking you this. It's a silly question. They give you a molecular substance and they ask you how many atoms are in it. You have to go away and get how many molecules firstly, because that's how it exists. Molecules. Now, the tags are very important. I went from centimeters cubed to litres to moles. You always divide to go into moles and you multiply to come out of moles. So there you go. And that comes out to be, I should have an answer for that. I'm ignoring the calculations here now because I think you can be doing that in your own time with a calculator. And this comes out to be, they've asked you how many atoms of hydrogen, which happens to be 10 of them, okay? This comes out to be 7.5 by 10 to the power of 21. 7.5 by 10 to the power of 21 molecules of C4H10. Now please, the single biggest mistake you can make is skipping one of these lines. Okay? The more lines I see, the more impressed I am. And I'm saying that to you now from the point of view, you're a much more dependable exam candidate when you do all of that. Okay? So we've molecules. They didn't ask you for molecules of butane. Read again. They're asking you how many hydrogen atoms. And you have the enormous task of informing them that every molecule has 10 hydrogen atoms. Every molecule, I personally would be writing that down. Each molecule of butane has 10 hydrogen atoms. So the answer then is 7.5 by 10 to the power of 22 atoms of hydrogen. Now, will you be careful? You have to get the molecules before you can get them, okay? Each molecule has 10 H atoms. Now, I can't impress enough upon you. People who are well versed in chemistry will tend to explain what they're doing as they go along. Calculations are not just about numbers. Getting the answer really is essential and it must be accurate. There's your answer, okay? Atoms of that. And that's that one. Each of them is a slight variation on the previous one now, and I have to be careful that you are dealing with all of them, okay? More than anything else, we have to work our way through that. Good. Now, the last question here on the screen. This one, I hope you can read it. You get a copy of this in due course. Calculate the number of molecules of nitrogen present in 5.6 litres of gas stored at RTP. Stored at RTP. Right now, they're each dealing with a different aspect of the mole, and please just be careful that, you know, they don't even mention moles in these questions. That's the point. You have to read that and say, oh, that's a question on the mole. They want you to go from one unit to another. The number of molecules of nitrogen present in 5.6 litres of the gas at RTP. 5.6 litres of nitrogen, be careful. Now they play with your head a bit here because sometimes they write it like that. And they would not give you that. They'd expect you to know, as a chemistry student, that a nitrogen gas is diatomic. They'd expect you to know that, okay? So that is not a formula to be given, be careful. So you have 5.6 litres of that. That's equal to 5.6 divided by 24.0 is going to give you moles of nitrogen N2. Okay, you're all right with that? That's what you divide by 24 and you have moles of nitrogen. All right, you need the scale from above just to see what you're at. 24, it's RTP. They don't usually say RTP at all, by the way. They've said it there, but they don't usually say that. Okay, they're usually presuming that that needs to be put into a practical situation. And that's equal to moles of nitrogen. Moles of nitrogen, therefore, you evaluate that, right? Get the value for that there and then, and they want to know the number of molecules of nitrogen, so it's going to be that 5.6 divided by 24.0 multiplied by 6 by 10 to the power of 23. Okay, and I have an answer for that for you. 1.4 by 10 to the power of 23. That's equal to 1.4 by 10 to the power of 23, and that is molecules, write it in full place, molecules of nitrogen gas, N2. And that's what they've asked you, to state the number of molecules of nitrogen. Read carefully now, please. It's very important that you wouldn't be picking up anything other than the correct solution. The more lines, the better now, please. Okay, I'd like to think you'd evaluate that next. I'd like to think that you show that multiplication and that you would use your calculator to get your results. There shouldn't be any issue with that. Now, I'm missing one permutation in this, so I better do something to give it to you. I'm giving you another question, and it's not on this list, but I'm giving it to you, okay? How many atoms in 11 grams of carbon dioxide? I'll write it here on top of the board. How many atoms in? Now, it's important that you are picking this up correctly. In 11 grams of carbon dioxide. In 11 grams of carbon dioxide. Excuse me. 11 grams of carbon dioxide. Good. And here we go, we're going to deal with that. How many atoms in 11 grams of carbon dioxide? Right? And so you're given grams and you're looking for particles. You're given grams and you're looking for particles. You need to convert the grams to moles, so you divide, and you convert the moles to particles by multiplying, okay? Very important. So 11 grams of carbon dioxide equals 11 divided by carbon dioxide. Carbon is 12. Oxygen is 16 by 2, and you add it together, and that's 44. Are you okay with that? 12 and 32 is 44. 44 divided by 44 moles, that's equal to a quarter, 0.25 moles of carbon dioxide. By the way, can I just make a comment on that? 11 grams of a gas is a lot of gas. Okay, so you're talking about a big quantity of it, okay? That sounds a small number, but it's a quarter of what I showed you already, okay? That'll be a significant amount of carbon dioxide. And there's moles, and they want to know how many atoms. So here we go, 0.25 multiplied by 6 by 10 to the power of 23. Do you know the label for this? It's molecules of carbon dioxide. And that's going to be, a quarter of that is 1.5 by 10 to the power of 23 molecules of carbon dioxide. Now please, I'm pleading with you again now, everybody. I'm pleading with you. Please, please, will you all make sure that you label everything, number, unit, and tag. Tag everything all the time, you won't make mistakes, right? So you have molecules of carbon dioxide, and they didn't ask you for that. I asked you how many atoms, right? I'm repeating again, how many atoms in 11 grams of carbon dioxide. And now you make a statement. Each molecule has 3 atoms. Okay, 1 carbon and 2 oxygens. So you multiply by 3. So the answer is equal to 4.5 by 10 to the power of 23 atoms. And for once, you cannot put a tag on it because some of the atoms are carbon and some of the atoms are oxygen. Okay, now please, you have every permutation there. Let me finish with that little frame now. Everybody should have that model in their agenda all the time. If anybody gives you grams of a gas, you can find out what volume you have. If anybody gives you grams of a gas, you can find out how many particles you have. If anybody gives you volume of a gas, you can find out how many particles you have. If anybody gives you grams of a gas, you can find out how many particles. So when you take it, please, all those permutations, you divide to calculate moles, and you multiply to come out of moles. And if you do that, generally speaking, you'll do very well.